If you think writing code is hard, try resolving some conflicts in Git. Now, let's say you're working on a personal project. Maybe you are writing a blog post, or you're designing a website, or building a small app. You're making progress, things are going well until you think, wait, what if I mess this up? And just to be safe, you save your project in a new file and you name it projectfinal.txt. And then after a few more edits, you save it again. Project final edited.txt. And later down the line, after you make some more changes, you save it yet again. Project final edited final. You know how it goes. Eventually, you end up with a folder full of files with weird names and you don't know which is which. Now, imagine doing this with a team, 3 or 4 people all working together on the same thing. Everybody's making changes, files are flying back and forth through emails or WhatsApp or Telegram or Slack. People are overwriting each other's updates. No one knows what the latest version is or what got changed or who changed it or why they changed it. It's pure chaos. And that's exactly the kind of mess that Git was designed to solve. So, what exactly is Git? You see, at its core, Git is a tool that helps you keep track of your work over time. Now, instead of saving multiple versions of the same file with different names, Git gives you a clean, organized way to manage everything in one place. This kind of tool is what we call a version control system. And all that it really means is that it helps you save different versions of your project as you make progress and lets you go back to any of them whenever you need it. In Git, these saved versions are called commits. Each time you reach a point in your project where your work feels complete, like maybe you have added a new feature or fixed a bug or cleaned up your code, you can make a commit. You can also leave a short message with the commit, like added contact form or fixed nav bar, so you know what that version was about. Git takes a snapshot of your entire project at that time and stores it safely. You can always go back to that version later, see exactly what changed, and compare different commits or even undo something that didn't work out. It's like it's like having a time machine or a personal journal for your project, one that always remembers what you did, when you did it, or why you did what you did. You see, Git doesn't just stop at helping you save your progress. I mean, let's say you want to try something new, maybe a complete redesign or a new feature or a different way to solve a problem. The thing is, you're not 100% sure it will work. And you don't want to accidentally break the part of your project or the version of your project that's already working. This is where Git gives you something really powerful called branches. A branch is like creating a separate version of your project where you can experiment freely. It's completely isolated from your main project, so you can test out new ideas without any risk. You can build something from scratch, make changes, even mess things up. And your original project or the original branch stays safe. If your experiment works and everything looks good and you love what you did, you can merge both the branches or the experimental branch with the main one and make it whole again. If it doesn't work, no worries, just delete the experimental branch, and it's like that risky idea that never happened. No damage, no confusion, and it's one of the reasons developers love Git, because it makes trying something new super easy, safe, and stress free. Now, Git works locally, which means everything you do with Git happens on your own computer. It quietly keeps track of your changes, let you save your progress in neat snapshots or commits, and helps you experiment freely without breaking other things. But here's the thing, what if you want to collaborate with others, or put your project online, or share it with the world? See, this is where GitHub comes in. GitHub is actually a code hosting platform, sort of like a Dropbox or Google Drive, but made specifically for code. It takes your Git tracked project and gives it a home on the internet. But it's not just storage, it's more of a collaboration hub. Once your code is on GitHub, you can access it from anywhere, invite teammates to collaborate, and open it up to the broader developer community. People can follow your progress, leave feedback, or even contribute directly to your project. And when someone wants to suggest a fix or an improvement or an addition, they don't need to email you a zip file or copy paste your code in chat. They can just go to your project in GitHub and start collaborating or contributing. Let's say your project is up on GitHub and someone out there finds a bug in your code. But instead of messaging you directly or filing a long complaint or writing a mean tweet, they decide to fix it themselves. So here's what they do. First, they can fork your project, which means they can make their own personal copy of your code. It's like duplicating your project into their own GitHub space so that they can experiment freely without modifying your version of the code. Now they go ahead and fix the bug in their version, and once they are happy with the fix, they can send you a pull request, which is basically GitHub's way of saying, hey, I have made some changes that I think improves or modifies your project. You can take a look and maybe add them to the original project. Now you get to review their pull request or PR. You can see exactly what they changed line by line. You can leave comments, you can ask questions or request modifications. You are still in charge. Nothing changes in your project unless you explicitly say yes. If you like what they've done, you can merge the PR or pull request, and just like that, their contribution becomes part of your code base. If not, no problem, you can decline it or ask them to revise it. It's one of the best parts of working in open. GitHub makes such kind of collaborations feel safe and respectful. Everybody gets their own space to work. Your main project stays clean and protected until and unless you decide it's ready for change. All right, now that we have a good idea of what Git and GitHub and all those things are, let's just go ahead and try it out. So, in order to try out Git, you have to install it in your system first. Now, a lot of operating systems like Mac and Linux comes with Git pre-installed, meaning you don't have to do any extra installations. But if you're using Windows, all you have to do is you have to just go to this website. You can just Google Git, and this is the first link that pops up. And inside the website, just click on downloads, and you can see the option to download Git in Windows. You can just download it and install Git in Windows. So once you have installed Git in your system, you can, in order to confirm the installation, you can just open a terminal, type in Git version, and it will show you the version. If you're seeing the version, that means your Git is properly installed. Now, another neat trick or another, let's say, standard practice is to add your username and email so that whenever you start making commits, Git will attach that username and email to that commit to identify that it's you who has actually done all those things. I mean, it's just a standard practice. So in order to configure your username and email with Git, all you have to do is use this command: git config global user.name, and then within quotes give your name. Like I've already configured it. So, and if it's the email, instead of user.name, just give user.email and give your email. It's that easy. So this, like I said, whenever you make changes, Git will tag your commits with these details. Now that we have installed Git and attached our name and email and everything with Git, let's just see how we can use Git to track changes in our project, right? So I have an empty directory here. Let me just go ahead and create let me just go ahead and create a new folder. I'll just call it sample project. Now let me just go inside the project and open a terminal there. And so in order for Git to track this project, you have to initialize Git within this project. And to do that, you can use the git init command. Now, when you execute the command, you can see that a new folder called .git pops up in your sample project folder, right? Now, this folder is typically hidden, but for the video, I have made it visible. So this is where Git stores all the history and everything related to your project, right? This is like the storage base of Git. Within the folder, Git stores everything, like all the things that it needs to track your project. All right. Now, in order to check the status of your project using Git, you can use the git status command. Now, we don't have anything in our project, so it will just say that we are on the master branch of the project. There is no commits, and there are no files or something. Like it literally says create some files to have some commits. So let's just do that. Let me just go ahead and create a few files. Again, I'm not adding any code. I'm just creating some sample files. Style.css. All right. So now within our project, we have 3 files, which is a change in our project. Now, if you type in git status, you can see that the output changes slightly. It says like, it's on the same branch, like master branch, no commits, but it says that there are 3 untracked files. Meaning Git has detected that there are some changes, there are some files in this project, but it is untracked. Meaning if you are taking a snapshot of or a commit of this version of your project, these files won't be included. And the reason is that we haven't told Git to include the files. And to tell Git to actually include the files in the next snapshot or the next commit, we can use the add command as it says here. Right now, there are a couple of ways to use the add command. Like you can actually add a very specific file. Like I can say that just track or just add this index.html file the next time we make a commit. But typically when you are tracking a project, you need to track everything within that project folder. So to do that, you just use the period symbol. This means that track every file within the folder, right? So I'll just give git add and the period symbol. Now if I do git status, you can see that Git has tracked the changes. Like it says that there are 3 new files. So next, if I take a snapshot of the project or try to make a commit of the project now, all these files will be included. So in order to make the commit, you use the git commit command. And what it does is, like as I mentioned in the first part of the video, it takes a snapshot of this particular version of the project. Now, there is nothing in terms of code here. We just added a few new files to our project. But for the video, that in and itself is a change. So we'll just commit it. So to commit the change, we'll do the git commit command. And as I mentioned previously, we can attach a small message with the commit so that we know why we made that commit. So I'll just say, I'll just use the -m flag and put a message, -m message, like M for message. So I'll just put a small message. I'll say it is the initial commit and it was about adding some files or adding new files, whatever. You can make it short. You don't have to make it this elaborate. You can just say added some files or something. So this is how the commit message looks like. This means that Git will take a snapshot of this particular version of your project, track all the files and all the changes and store it, right? So there you go. All right, now that we have installed Git locally, created a project and used Git to track the changes in that project, let's just move ahead and see how we can use GitHub to actually move our code online and do better collaborations. Now, as we have mentioned earlier, GitHub is an online code hosting platform. It is sort of like a Google Drive for your code. Like you can upload all your code online, you can share it with people, you can collaborate with individuals around the world, and it allows you to do all that from anywhere or any device because everything is online. So to do all this, all you need is a GitHub account. Now to get a GitHub account, you just have to go to the GitHub website and sign up. It's pretty straightforward. It's like everything else out there. So once you set up your account, like I already have my GitHub account, you can see that you can it allows you to host all your different projects. Like these are all the different code repositories or projects that I have. Like in a lot of them, multiple people are collaborating. I have collaborated with other people and their projects. So all of these things are managed within my GitHub account. So these are different code repositories. Now in order to transfer our local sample project to my GitHub, what I have to do is I have to create a new repository. First, let me just set the owner, and I'll call it sample project. Yeah, we have it. And Git will check if the name is available. You can set the visibility. Public means it will be accessible to everybody, like everybody can see the project. Private means only you and the people that you invite as collaborators can see that particular repository. And you can also add a readme, which is sort of like a file that you keep in your code base, which describes your project, how to run it, and everything. Now we don't need to add a readme now. And a gitignore file is sort of like a safety file. Like you can mention all the files that you don't want to, like while uploading all the changes or the files from your local system to GitHub, you can mention all the files that you don't want to include in the gitignore file, and it won't upload all those files. It's sort of like it's a way to prevent unnecessary files from being uploaded. And of course there is a license, like since many of the projects or a lot of these projects in GitHub is open source, it's always good to have a license. So now you don't need to add a readme or anything because we already have a code base in our local system. We are just going to upload that. So let me just create a repository. Right. So we have a repository set up. There is nothing in it, like no README or anything, and it shows you or it tells you like how to upload files or how to create a new repository in local and all those kind of things. Like we have. So what we need right now is this particular HTTPS URL. We need that to link our local project to this repository. So we are just going to copy that, and we are going to use that in our local project and link our project to this repository. All right. Now that we have created a GitHub account and set up a new repository for our sample project, we need to move all these files into our new GitHub repository. And to do that, as I've mentioned earlier, we need the HTTPS URL. So once you have copied that, just open a new terminal in our local sample projects folder and type in the command git remote add or origin and just paste that HTTPS URL of our GitHub repo. Give me a second. Yeah, let me paste it. All right. So yeah, just paste it, and then what you can do is you can push all these changes or all the commits to our GitHub repository, to our new GitHub repository. And to do that, just type in the command git push. Pretty evident. Minus u origin master. Okay, so yeah, so this is the command. It basically says that, all right, now send all these things, all the things that are in the commit to the GitHub repository. I mean, this git remote add, it basically tells Git that, hey, This is the remote version of the project where we'll push everything online, right? And with git push, we are saying that, okay, push all the commits that we have made locally to the GitHub, like to the online GitHub repository. Now the minus u origin master thing, it's basically a one-time thing. It basically sets the it says that, okay, this is the master branch. Here's where we will be pushing everything, but you just need to do it once, right? Next time, like if you are trying to push some new commits to our GitHub repository, you don't have to write all these commands, you just have to write git push. But since it's the first time, we have to set the default upload branch and stuff. So yeah, now once you have that, just execute, and you can see that everything is basically pushed. Now to see the changes, just open the git repository. There you go. Just refresh it, and you can see this. You can see all the files have been uploaded, the branch is master, and you can see our initial commit message that we gave while we committed, right? Like with that -m flag. So yeah, so now we have all our files from our local project. Everything is uploaded to our GitHub repository. So it's that easy. Now you can share the link of this file with people. You can ask them to uh, you know make contributions. You can even create separate branches. Now to create branches, you can see that there is this option called branch. You can click on it. You can now create a new branch. Let's say test. You have the master and the test branch. So creating a branch. Now, yeah, so this means that now your project have two branches. You have the master branch, which is the main branch, and you have the test branch. Now when you can uh, get this branch locally, test everything, and your master branch remains untouched, right? So this is the cool thing about GitHub. So it allows you to do all the features that you do with local Git, but it has a nice UI and easily clickable buttons and stuff. So yeah, this is how we can upload our project to GitHub, and open doors for better collaboration, visibility, and all those kind of things. Now that we have seen how to use Git, how to install it, how to use it to actually track our project versions, how to do commits, how to create an account in GitHub, how to set up a new repository, how to upload our local project to Git repository, we have learned a lot actually. So now the thing is, while we were doing all these things, we relied quite a lot on the terminal. Now, there is nothing wrong with it. Like the terminal is pretty handy. Like, you can do a lot of cool stuff with the terminal. Like, a lot of commands, and it actually looks cool. Like, when you're typing everything on the terminal as a developer, it looks kind of cool. But the thing is, if you're starting out, especially if you're new to GitHub and all those kind of things, typing all these commands or remembering all these commands can be a bit overwhelming. So there is a very clever workaround, and it involves Visual Studio Code. Now, if you are like new to coding, or if you have some familiarity with coding, you might have heard of code editors, like softwares that you use to create code, like programming files and codes and everything. And Visual Studio Code is actually one of the most popular code editors out there. Now, mind you, Visual Studio and Visual Studio Code, they are two different things. So if you're new and if you're trying to install it, make sure that you go for Visual Studio Code. Now, Visual Studio Code, like you can just go to this website. It's pretty easy to install. You can just download. Like since I'm using an Ubuntu, that's why it shows like these installation paths. If you're using Windows or Mac, it will show the corresponding ones. So yeah, you just have to download it, and it has a pretty neat UI, and it has a lot of cool extensions that you can use, which makes your coding life much easier. So the reason I'm telling you this is because even with GitHub, like rather than using the terminal, you can actually use a couple of extensions in Visual Studio Code to do all the things that we did, but with just a few button clicks. So I'll just open this project using a Visual Studio Code. You can see this, and in the Visual Studio Code, like if you look at the sidebar, there is this weird little icon. It's actually yeah, the source control icon. If you click on it, like I've already you know attached or connected my GitHub account to it. But if you have freshly installed Visual Studio Code, when you click on it, they will ask you to sign up with the GitHub account and stuff, so that they can access it. So once you have set up your GitHub account with this with the internal GitHub mechanism, or this tool in Visual Studio Code, it is much more easier for us to make changes and upload it to GitHub. For example, you can see that I have all the files. Let me just create another file. I'll just call it index.js. So there is a change. Now you can see that the change is quickly picked up by the source control option in Visual Studio Code, and it actually gives me a button to commit. So I can just click on this. I can click on this commit and push button, stage commit, yeah, and it will ask you to stage all these things, meaning add all the files to the commit. So you can just click yes, and it will show you this commit message, like this thing where you can add the message. I'll say added a new file. Yeah, of course, I'll just say file. Okay, and you just have to save it, and the moment you close this file, the commit will be pushed to GitHub. Like the commit will be made and it will be pushed to GitHub. Now if you want to see it, let me just go to my GitHub, my repositories, my sample project. You can see that it is updated now, right? And yeah, there you go. There you go. You can see that added a new file. It's there. So it's that easy. All right. Now we have officially covered quite a lot. I mean, from installing Git, using Git to track projects, GitHub, creating new repositories, uploading our local project to the Git repository. We have covered a lot. Now for the final stretch, what we are going to do is we are going to see how we can make a contribution to a separate repository, not something that we own, something that other people own, right? For example, now I'm going to show you how to make a submission to the Web3Compass 30 Days of Solidity Challenge submission repo. So for those who don't know what the 30 Days of Solidity Challenge is, it's a month-long challenge where every day you will be presented with a Solidity smart contract challenge, like to create a particular Solidity smart contract. And each day, with each day, the intensity of or the complexity of the code or the challenge will increase. And by day 30, the idea is that the people who are participating would have learned quite a lot about Solidity or creating smart contracts using Solidity. So every day they have to submit the solutions for the challenge in the solutions repository. So we are also going to try and make a submission. So to do that, let's just go to the repository. Wait. Yeah. I mean, I can go there, like, yeah, directly, because I'm also working with Compass, as you might have already guessed. So yeah, so this is the 30 days of Solidity submissions repository. So typically, like these kind of repositories will be owned by somebody else, and we would have to make commits or contributions to it. So the first thing that we need to do is we need to fork it. Now, as I mentioned earlier, forking means creating a copy of this repository onto our own GitHub, right? So to fork this repository, you just have to click on this fork button here. You can see that now it's Web3 Compass solidity, 30 days of solidity submission. Now I'm saying that I need to create a fork, and the owner will be Seduraman, and the name of the repository within my GitHub will also be 30 days of solidity submission. And I'll just create a fork. Now you can see that it changed to Seduraman, meaning this is now a copy of the 30 days of solidity submissions, and I created this copy from, like you can see, forked from the original repository, which is owned by the Web3 Compass team, right? So this is how you create a fork. Now I can use this fork, or I can create, or I can modify or add things to this fork and submit all the changes to the Web3 Compass team. I'll show you how to do it. All right. So now in our GitHub repository, we have the fork, or the copy of the official Web3 Compass 30 days of solidity submissions repository. We can make changes to the copy that we have, and then we can submit it to the Web3 Compass team so that they can review it and maybe even merge it, right? So to do that, the first thing that we have to do is we have to get all this to our local system. And the way we do it is we will clone this repository onto our local system. So to clone the repo, what you have to do is again copy the HTTPS URL of our local repo. You can see that I'm copying, not local, sorry, like I'm copying the URL of the fork that we created. Okay, not the original one, the fork that we created and the one that exists in our GitHub, right? So I'll copy the URL of the fork. I'll go to our projects folder, open a terminal, type in git clone, right? And paste the URL, HTTPS URL. And yeah, once this is done, you can see that the folder is here, like along with all the code and everything. Okay, so now let me just open it with VS Code so that it is easy for me to, you know, commit and push and everything. Now you can see everything, right? Like all these things, all the folders and everything. Now you can't, like, even if you try and change any of the code in this, any of these folders, and you submit it as a submission, the people who review will figure it out, and they won't allow you to make those changes. So as a sane person, let's just go ahead and create our own submission. So I'll just create my folder along with the rest. I'll call it Setu. I'll create a new folder for each day. So this is day one. So let's say day one. And within it, I'll create a new contract. Let's say first contract. You can name it anything. Day one contract. Day one dot sol. And within it, I'll just create SPDX. Well, yeah, I'll just put it like this, and contract. Oh yeah, so I'll just create a, I mean, I don't know if it's accurate. Yeah, I guess it's accurate. I don't think this is the challenge, but anyway, it's just an example. Okay, so I have a day one contract. So this is my submission. So now I've created it in my folder, day one dot sol. This is the contract. Now you can see that our source control in VS Code has detected the change. Now I'll just commit and push. Yes, and the message has to be clear. Day one submission, and it will just commit and push. Now what you have to understand is we are pushing all these changes to the fork of the 30 days of submission repository that we have in our GitHub. We are not pushing it to the official Web3 Compass one. Now if you go to the our fork, you can see that there is a new, like, change right in the submissions. You can see that our folder day one has come in, like, now you can see the message and everything. Now what you have to do is, in order to make the contribution, you have to click on this contribute. Like, once we make any changes, you will get this contribute button. Click on it, and there it will show you to open a pull request, which is GitHub's way of saying, okay, I have made these changes. So you can see that the pull request is to actually merge or add these changes to the Web3 Compass 30 days of solidity repo to the main branch from the 30 days of solidity repo that we have. And you can add some descriptions if you want, or you can just simply create a pull request. Okay, once you create this pull request, it doesn't mean that all the changes that you have made now is officially now part of the Web3 Compass, official 30 days of submissions report. Like, if you check that, you know, there is no Setu folder or anything, right? Like, within the pull request, you can see, I think, yeah, you can see your pull request. So, in order for those changes to appear in the official repository, the Web3 Compass team has to evaluate it. They have to go through all the changes that you have made, like the file changes that you have made. You can see all these things here, and make sure that everything is proper, and then they will merge this pull request, right? They will merge this pull request if everything is fine. Now I can see the merge pull request button, because bit of a flex, but I'm the one who is reviewing the pull requests, right? I'm part of the Web3 Compass team, but I don't think I'll, like, let this pass because the contract is stupid. Anyway, so bit of flex there, but yeah. So the only way for these changes to be reflected in the original Web3 Compass repo is only if the team accepts this pull request, and if they click on this merge pull request. Once the pull request is merged, meaning it means that all the changes that you have done from your fork repo will be accepted into this one, and all the changes or your submissions will be officially accepted. Now you can make multiple pull requests, no issues, but everything will go through the same process. So this is how you can actually contribute to another repository. You can't directly make the changes. You have to fork it. You have to clone it. You can make all your changes. Then you have to create a pull request, which will be reviewed by the other person or the other team. And if everything is proper, they will merge that pull request, and thereby accepting your changes to their code base. So that's how the whole process works. And I guess we have covered quite a lot for one video. So I guess this is it. I would suggest you guys to go ahead and try the 30 days of solidity challenge. It's quite fun if you love, Web3, or if you want to get into Web3 and or the solidity development, give it a go. And I guess with that, we are concluding this video. See you guys on the next one.